Okay, so yesterday we saw about MPLS, okay, ADSL line and the lease line connection. Okay, so today let's see about the IP services. So HSRP is hot standby router.
So basically, HSRP is a gateway redundancy protocol, right? It is used for prioritizing one router. If there are two routers, it is used for prioritizing one router over the other, and
Correct.
it prioritizes the other router by priority number. Right? The highest the priority number, that will be
The
the
primary. Right.
primary.
Right.
Okay.
That is the concept. So it's
All right.
mainly used for redundancy only. Like you said, it is mainly used for redundancy. So to avoid single point of failure, right? So if the primary goes down, the traffic will be automatically switched over to the backup. No manual intervention is required. And also, if the active router is the primary router comes online, then all the traffic again will be switched over to the primary again. So there are organizations who uses the same bandwidth for both the links, primary, secondary, say 10 Mbps, 10 Mbps. But again, since the backup is just going to be ideal most of the time, there are certain organization uses a minimum bandwidth on the backup, just to want to make sure the network is available. Business is running at least for some time until the primary restores. So they might purchase a 5 Mbps link. Okay, like we said yesterday, we saw MPLS link, which is expensive, no? So a primary backup, both will be MPLS with same bandwidth or different bandwidth, 5, 10 and 5, okay? Or primary will be MPLS, backup will be an internet-based link, ADSL link, internet-based. It is not an MPLS cloud. It will not go to MPLS or fiber cloud with high speed routing happens. No, the backup will be of very slow link, because at rare scenario only the backup link will be triggered. So they will have a lesser bandwidth or a cheaper internet line or a WAN link triggered. That case is also there. Okay, so HSRP, it's a Cisco protocol, Cisco proprietary protocol. So it can be supported only on Cisco routers and switches. So it works on priority basis, as you said. Okay, priority based, priority numbers can be set. Highest priority will be the active router. Okay. And what else? Nothing much on that. We'll just directly go with the configuration information. Okay. So how are we going to enable the configurations on the... So first we need to choose which will be the primary router and which is going to act as the backup router. We need to choose. Based on that, we have to apply the configuration on the LAN interface of the router or the switch. Okay. I share you in a topology diagram, which typically...
In a set of routers, will there be only one backup router?
Set of routers, no. See, there will be one primary, one backup, and one secondary backup. Maximum 3 routers only will be supported in this technology or the routing protocol, whatever you say, the protocol.
Okay.
HSRP or VRRP or GBLP. Maximum 3 routers.
Okay, VRRP is multi-vendor, right?
Yeah, GBLP. VRRP is multi-vendor, yes. Okay.
Okay.
So let me put up a similar topology diagram. So on the LAN end, there are, see, on the router, it's Cisco who provides the router. Then Juniper routers are there, Meraki routers are there. Okay, on those things and all, the HSRP is supported only on Cisco. On Juniper routers and all, VRRP is supported. Similarly, on the LAN and also Cisco is there. Then HP switches, Aruba switches, and all are there. So for those devices and all, again, we need to go for a VRRP only. Okay. Okay, you can see my screen, right? This is on the LAN end. So like how we enable route on the router level, on the layer 3 level, HSRP, like primary backup and all. On the switch end also, we can enable primary backup switches. So it is very important for a big organization to run a switch with primary backup setup. But on the switch end, you can actually connect devices over these switches and all, but it is not like the utilization of the backup switch will be ideal or less. It is not like that. Still, it will be functioning. Whatever device is connected here will be routed through this back-to-back link through switch 1 and then goes to the router. It happens. Okay, but on the router end only, what I meant was like on the backup, the WAN link will be in idle. Okay, it will not in use. But on the switch, it will be still functioning, but it will be redirecting all the traffic to the primary switch. You'll be redirecting the traffic to the primary switch. And the primary switch will be the only point of contact to send the outside traffic to the router. Okay. So this is one similar topology where primary backup will be there. So the IP segment 172.16.10.0 is being used for VLAN 10. Okay. So there dot 2 and dot 3 are the interface VLAN IP for VLAN 10 configured for each switches, and dot 1 will be the default gateway. That is dot 1 will be the standby IP address. So if you remember, since you know the concept, if you remember, it will be easy. I'll put up. I don't know whether I can share multiple screen. No, one screen at a time. What is this? Okay. So one screen at a time. I'll share the configurations on how to enable. Closed it all. Okay. So now the screen is visible, right? Okay. So in switch 2, okay, switch 2, what we are going to configure is under interface, it's a configured terminal. We are going to inside the configured terminal. Just showing you. Okay, then you will be inside the config mode, and there you need to go inside the interface VLAN. So on the switch now, you can apply this HSRP configuration in all the VLANs you have. If you have one VLAN, apply it on one VLAN. If you have multiple VLANs, apply the HSRP configuration, enable HSRP on all the VLAN interfaces. If you're going to leave that interface without an HSRP configuration, then what is going to happen is for that particular segment, there will not be any redundancy. It is only dependent on the switch, whatever it has been applied, or primary switch. If the primary fails, if the primary switch goes down, then that particular VLAN segment will be isolated, will not able to send traffic in and out or within the LAN. There will be an error. So it's a risk there. So it's better to apply HSRP on all the VLANs, whatever is there applied on the switches. Whether it is a default VLAN, VLAN 1, apply HSRP. VLAN 2, VLAN 3, how many ever VLANs, but it's a very simple configuration only, okay? Under interface VLAN, obviously under interface, there would be an IP address configured, right, on the core switch level. I'm talking about enabling HSRP in the layer 3 switch. Only layer 3 switch supports IP routing, and there only we are going to create a switched VLAN interface as VLAN 10, interface VLAN 10. On L2 switches and all, okay, these are layer 3 switches. The symbol says layer 3, a star kind of symbol. This is a layer 2 switch. On layer 2 switch, it is not going to support layer 3 routing. Okay, so only one VLAN will be configured on that switch. That means like all 24 ports will be assigned to a VLAN. Only that VLAN can be enabled on that particular layer 2 switch. So HSRP can be applied only on layer 3 switches. That is what I want to mention here. So in the layer 3 switch, definitely we will have interface VLAN configured for all the VLANs. That we call it as switched interface. SVI interface is switched VLAN interface. In the interview, if you call SVI, then you can say it as a switched VLAN interface. That is nothing but we are configuring, we are enabling a virtual. Okay, it's not VLAN, virtual. Sorry. Switched virtual interface. Okay. So in the switch, there is no physical interface for any VLANs, right? There are physical interfaces on the switch. That is fast Ethernet 0/1, fast Ethernet 0/2. That are physical interfaces. For VLANs, there are no physical interfaces. We are enabling a virtual interfaces for the VLANs to enable IP routing in the LAN end or in the layer 2 end. Okay, so interface VLAN configuration. Okay, so SVI is nothing but switch virtual interface, that is interface VLAN. We are manually creating a virtual interface for each VLAN. So that is interface VLAN 10. On the interface VLAN 10, anyways, there would be an IP address already assigned. Okay, 192. Okay, here they have given 172. I'll use the same one. 172. 16.10.2, 255.255.255.0. Okay. So now this is given. Now I want to enable HSRP. So what I will do, I will configure one virtual IP. Okay. So that virtual IP is going to be acting as a gateway IP. Okay. That is standby. We have to give some instance number 1, 2, 3, 4, anything, some instance number, because we have multiple VLANs. So for multiple VLANs, we have to keep on changing the instance number. Okay. So standby 10 IP 172.16.10.1. So this will act as your default gateway IP. Default gateway IP for this segment 10.172.16.10.0/24 segment. This is your default gateway IP. You cannot give 10.2 as your default gateway. If you're going to give 10.2, it will work. But if the switch fails, then there won't be any connectivity. Where you will enter this default gateway? On all the devices in your LAN, definitely there would be a default gateway. Okay, on your computer if you see. Okay. Once again. Okay, so on your computer there will be a default gateway. On your network printer there would be a default gateway. On your server, yes, there's a default gateway. So for any network devices on the LAN, okay, there will be a default gateway IP configured. Okay. So if there is an HSRP enabled on the switch level, on the layer 3 level, definitely you have to use the standby IP address, whatever configured on the layer 3 switch as the default gateway. Remember that. Okay. On the DHCP also you need to use this default gateway only. Okay. So that is the stand. But as per HSRP, yes, this is the default gateway or the standby IP. We call it a standby IP for this VLAN. Okay. Now, standby. Nana. Okay. So standby 10 permit command. Why permit needs to be used mandatorily in the HSRP is in order to, like, when the primary fails, the traffic is moved to the backup. And again, when the primary comes online, the traffic has to switch back to the primary again, right? For that, we need to enable this permit command. Okay. Once again. Okay. So again, there's one more command which we need to use is priority. Okay.
Can you write in brackets what is that preempt?
Permit is, that's what I told you, no?
I did not understand.
Okay. So primary backup is there. All the traffic is going via primary. Primary fails, right? So all this traffic are automatically switched to the backup now. Okay, backup with the backup, the network traffic is in and out is working fine. And at the same time, primary line is restored. It came online again. Okay, so at that time, this backup router has to send all the traffic to the primary as previously how it was going through the primary. It has to send back all the traffic to the primary again. In order to send this traffic, or in order to inform this device that you are still a backup, not the active router, the active router has come back online. So you need to send all the traffic to this active device again. Why? Why it has to send all the traffic to the primary again? Because there are chances primary has higher bandwidth, backup has lower bandwidth, or primary has an MPLS line, a high speed fiber line, and backup has a normal base internet line, right? Traffic or user network traffic cannot be on the backup line for a long time. Backup is just for the backup purpose. If something fails on the primary, it has to hold the traffic for a while without any network downtime or without any business impact. For time being, it has to hold. For that reason only, we have enabled the backup. So the backup should know his role is not the primary or active. I need to send back the traffic to the primary when it comes online. Anytime it can come online. Immediately after 5 minutes or 1 or 2 hour or 1 day, 2 day, anytime. Whenever it comes online, it has to send it. So what command is instructing the backup to send is this command, permit command. Okay. And since we have already set the standby priority, standby 10, priority as 110. So this will be the highest priority. So with the priority, it will check, okay, to this device, it will check, okay, I'm having the least priority and this router is the highest priority. So that is the active, will send back the traffic again. Okay. A similar configuration on the switch 3 we'll see.
So what is the primary? I'm sure that once I've worked on these HSRP protocols with the for the routers, but I don't know whether I've used it for switches or not. And what is the primary IP address? Where can you see it?
1 second. What is the primary IP address you are telling?
Yeah, what is the primary switch? Where is the primary switch in this?
Primary switch is 10.2. Okay.
So, okay. That is switch 2?
Switch 2, yes.
Okay. So now you're configuring switch 3.
Yeah.
Okay. In HSRP, we don't use the term HSRP, but in VRRP, we use VRRP.
Yeah.
But in the commands, CLI, it will be there.
Right, right.
Okay. Sometimes I get confused.
Yeah. Yes.
So this is standby, priority, and all. Okay. So what is the priority number of the primary IP address?
Sorry,
No,
what?
sorry, primary switch. Hello.
What was your question?
What is the priority number of the primary switch?
Primary is 110. I'm going to configure the backup with the lower value actually.
Okay. But I think, okay. So first, how will we decide that switch 2 is the primary?
See, in a net, that's what we need to design. So when you design a network LAN, anyways, a high-end layer 3 switch where you will place it on the core level. Only on the layer 3 switch you are going to introduce the VLANs of all the IP addresses, VLANs, all will be done in the core level only. Okay, so I have two core switches, and behind this core switch, I can have 20 or 50 access switches connected. 20 or 50 access switches, each of 48 port switch. 48 or 40 users can be connected in each of the switches. So my network is a very big network. Okay, so I'm going to design the network. So, example, okay, if you have a 𝐀𝐂𝐓𝐄, just tell me how much is 40 into 40 into 50 is how much? 2000, huh?
Yeah.
Okay, so I have 2000 users in my office. So for 2000 users, how many VLANs I want to create? How many VLANs I have to create for 2000 VLANs? Or how many IP segments I need to create? One segment, 1/24 segment will have 256 IP addresses. Okay, so how many segments I need to allocate now? 256 into 4 is 1000. 250 into 4 is 1000, right?
Yes.
So I need to go for 8. I need to create 8 VLANs for users alone. Then I can segregate one VLAN for servers. Servers might be like 10 or 15 servers for 2000 users. Fine. A small IP segment. Okay. So this is 8
Yeah.
VLANs /24 VLAN. And 1/24 for server. Again, one smaller segment /26, oh sorry, /26 or something for network printer. Okay. So that anywhere, any floor you give a print, you will get a print, because it'll be network printer will be in sharing in the organization. So you can sit in any corner of the floor, give a print, and you will get the printout in one location where the printer is installed, and you have to go and take it. So one for network printer, and there would be CCTV cameras and all. Access doors in the organization and all will be configured with IP. So you need to segregate that in a specific VLAN. Okay. Then the admin people, HR people, if you want to segregate, you can go for a different VLAN. So likewise, you need to think about how you want to design your LAN. Based on that, you will come to know how many VLANs you need to create. So this many VLANs, I need to first configure in the layer 3 switch. On the layer 3 switch, I need to enable first. And then on each of the L2 switches, I need to make sure who is going to sit or who is going to get connected on those L2 switches. Is it the HR user is going to sit, or is it the server, or is it the admin users or network printers? So when you decide who is going to connect on the switch, based on that, you need to enable L2 VLAN on those switches. So that's how you need to design. So when you design a network, these things and all will come in your mind, and based on this only you can go for the configuration. A high level high level network design, you call it as HLD or LLD. We call it as தண்ணி இருக்குதுல குட்டிடும்.
Okay.
Yeah. Okay. Daddy. Daddy. HLD, high level design, LLD, low level design. So you need to enable, you need to configure a design document to be prepared, showing a high level network design or low level network design. Okay. There you will get a clear understanding on what you're going to do, how you're going to place your net switches, L2 switches, L3 switches, where you're going to define VLAN, what is the HSRP IP. First, you need to allocate IP address for 8 VLANs. So allocation of the IP address. From there, you need to allocate IP address for HSRP, VLAN, IP, default gateway. Everything should be reserved. These IP addresses and all is being used on the switch, so it should not to be used on the end user machine. So before that, you need to allocate, reserve in the DHCP server.
Okay.
Okay, so once again. Once again, huh? Okay, sorry for holding you. So, so that's a. So there you will know which will be primary, which will be backup. Okay. So now I know my switch 2 will be primary, switch 3 as backup. So accordingly, I will configure the same IP. The same configuration will be applied here also. Not the IP address. Okay. These two, standby, permit. Okay. And priority, you need to give a lower value. So priority 100. So this means switch 2 is backup or the secondary one. Okay. And here one more thing, forgot to mention. Yeah, correct. So here standby priority 100 means it is backup. Any value with the lower priority will be backup. So here you need to know this IP is the major IP which you need to like use it for default gateway IP for any of the device in VLAN 10. Any device you want to put in VLAN 10, that device should have this IP as default gateway. It can be a PC, it can be any server or a printer. Any device, whatever you want to put in VLAN 10, this will be the default gateway. Why? Because that device, when it comes online in the network, it will see what is the default gateway IP. 10.1. Okay, then 10.1 is there in the switch. For any traffic, it will try to reach first the default gateway. Any traffic from your PC, when you want to browse something, okay, when you want to browse something in the internet, or when you want to send a file or download a file from the server, okay, anything. The server is not here. Server might be connected in a different switch, but you want to download or access that file remotely. Okay, at that time, the PC sees only this default gateway IP. If that is live, it will try to send an ICMP packet. Okay, if that is live, then it will come to this switch, primary switch. Why? Because default gateway holds better on the primary due to the priority. It will not go to the backup. Okay, so it will come to the primary switch. From there, it will access whatever resources it wants. Okay, say the primary switch is down now. What happens in that scenario? Still the default gateway is live only, right? This virtual IP is alive only. It will try to reach this IP, but it is active on this device, the backup device, and still able to access its resources through the backup device. So on the PC level or on the end user level, okay, on a mission level, it does not know which switch it is going to. It will go only to the default gateway IP. It will not know whether I'm going to switch A or switch B. Okay, is it a layer 2 switch or a layer 1 switch or whatever may be. It does not, or it is least bothered. It will check only default gateway is live, pingable, reachable in the network. Yes, then that if I hit the default gateway device, then I will be able to get the required resource access for me. That is the concept. Okay, the default gateway should be live. Okay, and if I hit the gateway, I will be able to get the required resource. Say if there is no concept of HSRP. Okay, so these configuration and all will not come into the picture at all. So at that time, what IP address I will use as a default gateway on my PC is .2. Whatever is the switch SVI IP .2, that is the default gateway IP for this VLAN 10. Okay, so your network devices on the LAN end should use 10.2 as your default gateway. Since HSRP is involved in your configuration, you have to use this standby IP. If you are not using the standby IP as default gateway, I mistakenly you started to use 10.2. Okay. Primary is live. 10.2 is also live since it's configured under VLAN 10. You'll be able to access everything. But if primary fails, from the PC level, 10.2 is not reachable, right? If you ping 10.2, because this switch completely goes down. So this IP is not reachable. At that time, your network traffic is dropped. Your packet is dropped. It will not go to the backup device. Why? Because of very minor mistake done on the default gateway configuration on your PC level. Very small mistake. Instead of 1, you mistakenly configured .2. Okay. So that time there would be a huge impact. You will be checking everything. Okay, you'll be checking the cables, you'll be checking what is the network path, is there any other device which goes down. You'll be checking everything, but people will forget to check the default gateway IP, whether that is pingable or not. Is it reachable? Is it correctly configured? So that's what, whenever you start a network troubleshooting, you need to go from the layer 1 level for any network troubleshooting. Directly, you should not go. If from your PC internet is not working, you should not go, okay, the internet site is down, or your WAN link is having issue, or it is having a high bandwidth utilization issue. Do not go directly there. Go from the layer 1. Check your cable, check your PC connectivity. Check if from your PC you are able to ping the neighbor devices or their default gateway. From there, if you start to troubleshoot, it will be easy for you to isolate. Mostly, all the network problems, apart from the major WAN link down, okay? Apart from the major WAN link down issue, most of the problems will lie on the layer 2 only. Most of the problems, like the cable will not be connected properly, or the IP address misconfiguration, IP, only those things only, like most of the issues will solve in the layer 1 level. If there is a huge impact where say a group of users are impacted, okay, multiple users are impacted, then you can check on the configuration level on the switch. If the switch is still online, still in working condition, but there are a huge number of users impacted, then you can go log into the switch, check for the configuration, what is working, what is not working, how it is configured and all.
Yeah.
Then on the switch, after checking the switch, you can go to the router. If there is any network routing loop is not happening, or if there is any network advertisement routing is not happening for a particular segment of IP where a group of users are impacted, then you can check on that. Okay. I think it's just a simple concept HSRP was about to taught today, but I went to an overall this thing. That's what, very simple. If you enable this, the HSRP is enabled. But why we are using HSRP is what I'm trying to explain this in this way. Okay.